Welcome to the lesson on Ohm's law. In this, resistance is a key element in an electrical circuit. In animation mode, we will use a light bulb to demonstrate real electrical resistance. Let's designate the ends of the conductor with symbols A and B. If charges are placed on one side of the conductor, a Coulomb force will arise, moving the charges to the other side. Now we will place charges at this point and see how they move to the right. When the number of charges at the ends of the conductor becomes equal, the electric current stops flowing. Charge accumulation creates an electric potential. Electric potential is denoted by the symbol phi and is measured in volts. The potential is recorded with a minus sign because negatively charged electrons create a negative potential. Currently, there is an equal amount of charge and equal potentials at the ends of the conductor. Let's observe how potentials change as charges move between the ends of the conductor. For this, we pause time and add charges. At this point, let's unpause time and observe the change in potentials. Thus, the movement of charges lasted until the potentials became equal to each other. Try selecting potential values yourself to explore charge behavior. To keep charges moving constantly, we need to maintain an electric potential difference.